Welcome back everybody to Desktop Inventions. Today we're going to be looking at an optimization video looking at the super pop-up towel hanger. Now we're going to take Elon Musk's 5-step process to improve manufacturability, and we're going to see before how many of these I can produce in a 24-hour period and after how many I can produce in a 24-hour period. So let's get started. So let's take a look at the 5-step process. So the first step in the process is make the requirements less dumb. So in a pop-up towel hanger, we definitely need a requirement for something to pop up, and we need a requirement to hang towels. So those cannot change, but another requirement is if you print this yourself at home, you need to insert screws. So that's one thing we'll be looking to eliminate, is getting rid of the screws. Moving into step number 2 is delete. Delete parts and processes that are unneeded. So an example of that again is the screws, eliminating those from the design. Now step number 3 is to simplify. So the remaining parts and processes you couldn't delete, you want to simplify those as much as possible. So with that, we'll be removing extra support material that's not needed. Step number 4 is to accelerate. So be looking at the 3D printer settings and how to accelerate the manufacturing of this. And step number 5 is to automate. Once you've completed steps 1 through 4, you're happy with your design and its simplicity, then you go ahead and you automate the whole process. Alright, before we get into the improvements and optimizations here, let's take a look at the original design. That's sliced at 8 hours and 27 minutes. Take a preview of how that looks. So that will be our baseline. So let's get that saved and printed out. Alright, got the base design printed out here. I'm going to go ahead and depanel it, assemble it, and paint it, and see how long that takes for the original design. So let's go. So there we have it, about 18.5 minutes to get through the depanel, the assembly, and the painting. Probably round up to 20 minutes to include the character piece portion, but that'll be our baseline. Now let's get to the improvements. Alright, let's take a look at the design updates here with version 2.0. Right off the bat, you can see I updated the question mark to follow the 8-bit style artwork there. And let's look at step 2 specifically with reduce and delete parts. So you can see in the back here, I have removed all the screws. There used to be some screws to hold this lid on. Now if I hide this box piece, you can see there's just a couple little nubs, and those will snap into the box here. Now let's take a look at this hook area. Before there was a screw that screwed into this hook piece to constrain it sliding up and down. Now if I hide the box part, you can see it's just a cantilevered lever arm here that will bend back as you install it, and that will snap into place. And that will constrain that. So all 3 screws eliminated from the design, no more external hardware needed. So let's take a look at the progress we've made so far. So when we start out, we're at 8.3 hours to do the full print, and then we went through step 2 to delete the parts, deleting the screws to assemble that, and it got down to 7.5 hours total print time. So a little bit of improvement there. And then we go ahead and look at the time to depanel and assemble. The original design, that took about 20 minutes. Now it's removing the screw and deleting parts. Got down to 13 minutes, so pretty big improvement there. Now that we've got the new design printed out, let's take a look at the changes. So on this base piece, we've got rid of most of the support material needed. On the back side, there used to be quite a bit here. Now I've just got a couple little pieces under these sliding parts and one little piece on the inside here. And for the hook piece here, got rid of all the support material that was in between these 2 teeth here and the support material on the back side. So now we basically just have a little bit on the bottom here that rips off and you're good to go. And for the gear, there is no support material, so just have to take it off and clean up a little bit. Now with the latest update on the lid design, I'm comfortable to print it on its back like this. Before I had it printed on the side because I was worried about the strength of these hinges. So that alone reduces the print time because it doesn't have to print it vertically. And this whole area no longer has support material. So now just a little bit of support material on the bottom and it's good to go. Alright, now let's take a look at the benefits we got from the step 3 optimize. So in the total print time went from 7.5 hours down to 6.6 hours. So some pretty solid improvements there. And then on the assembly side, able to get from 13 minutes down to 11 minutes there with some of the improvements made. A lot of the improvements there, just less time spent depaneling the parts. Alright, here's the first total print, all 4 pieces after the improvement. 3 hours and 59 minutes. You can see here the print was just too fast. It was really compromising the quality. It doesn't really work. It's a pain in the ass. A lot of parts that weren't fitting together, but it was a big struggle with the low quality of the print to cut and grind a lot of pieces down. I would call this one a learning experience. All right, now let's take a look at step 4, accelerate the process. So pretty drastic improvements here. This was the hardest and most difficult section to do, because as we were trying to accelerate things, the print quality really dropped down and some of the depaneling and things got worse actually. So it took a lot of time and a lot of prints to kind of balance those settings. So again, down to 4.2 hours for the total print. And then looking at step 4 on the depanel and assembly process, not so much improvement here. In fact, it was more so doing everything I could not to increase the time to depanel and assemble. And I think overall the process got a little bit harder, but the reason the time got lower is because after assembling this so many times, I just got better at that process. Alright, let's take a look at step 5 to automate. So I didn't have a good way to automate this without getting extremely complicated and extremely expensive. So I thought one sort of way to automate is to print 6 at a time. So at least this way, if I want to print 6 towel hangers, I only had to do 2 prints instead of doing 6 individual prints. So in a way, you could call that a little bit of automation. And then let's look at the improvements got from automation. So on the total print time, got down to 3.8 hours. And that got me under the 4-hour mark. So theoretically able to get 6 prints in one day. And on the depanel and assembly time, I was able to cut things down to about 9 minutes just due to the batch processing nature of doing something 5 times in a row. You do it faster than just doing it once and switching to another activity. So some slight improvements there. Alright, so here's a graph to show just how much the manufacturing speed has increased over time. When we started out, it could produce less than 3 parts in a single day. Now, with all the improvements, it's more than doubled to about 6 parts per day. Alright, great. So we've reduced the labor time and the printing time, but what does it all mean? So I made this view here to tie everything together. In the top left there is showing the printing time and how that decreased. And in the bottom left is showing the labor and assembly time and how that has decreased. And the bar on the right is showing the overall cost makeup, and the orange and blue boxes in the top, that is showing the labor and material, which is related to the printing time. So you can see that's a much smaller portion of the makeup. Then in the bottom of the chart in gray, you can see is the labor assembly portion of the cost. You can see that is a much more significant portion, and it's reduced a lot in cost from version 1 to version 2. So, did manage to cut the total cost in half and increase my daily throughput by double. So, went from less than 3 parts a day to being able to do 6 in a day in a 24-hour period. All this effort, though, took a lot of trial and error, and actually took more effort to do this design improvement than it did to do the original design in the first place. So, if you're just casually printing parts for fun at home, I would not suggest this exercise. But if you are looking to improve your daily output and have a sort of a business model associated, this could make sense for you. Again, maybe if your volumes are more than 20, 30, 50 parts that you're producing. So I'd have to agree with Elon on this one, that creating the first prototypes was much easier and increasing the production capacity was a lot more challenging. Anyways, if you've made it this far, thanks for watching, and I'll see you next time on the next video at Desktop Inventions.